Dear students, hello. Today we continue with the waves, and we have today a new subtopic about waves. So I will speak about with you stationary waves. So let's start our lesson and see what is a stationary wave. So when we first speak about stationary wave, we have the terms like progressive and stationary waves. If two progressive waves of the same frequency travel in opposite direction at a stationary or standing wave is produced. So here we may see our first wave, so wave A and wave B. So they're traveling in opposite direction. One is in positive side, another is in negative side. So in the positive side, we call it like antinode, maximum displacement occur. Here we know that. And also we have node. So what is node? Node displacement occurs. So in the node case, we can see that the resultant will be in a straight line. It means here happens node. And also here about this case, we also can say that stationary waves are not literally stationary, but in contrast to progressive wave, energy is stored and not transmitted. At this point, dear student, we have a small demonstration. So let's see for this demonstration and speak further about superposition of stationary waves. So we have with the red color wave A, blue color is a wave B. And here we have the resultant picture of A plus B. So amplitudes are same, wavelengths are same, frequency are same, and phase is also same. So now I will first change the amplitude of the wave A. Let's see, let me make it 40. So when I make a 40, the amplitude, you can see the difference. So the difference in A plus B. Let me also here increase it also for 40. So you can see, we can see in some points that it gets cancelled. But if we have the different amplitudes, we can see that they are making a cancellation. And also, let me turn back to 2020 for all of them, and I will a bit change the wavelength. So if I will change a wavelength, it gets 100, and it's like 80. So wave A and wave B. The wavelength for wave A is 100, for B is 80. So you can see the difference from A to B. Let me again also increase the wavelengths of B. So you can see nothing has happened. But if we have the difference wavelengths, and you can see in here. So I will also turn back their old position. I'll make it at 80. So let's see about the frequency. I'm changing the frequency of A to, let me make it 3, and for B it's 1. So we can also here see the demonstration about their case. So dear students, I think it's all clear for you. So also we have here one more demonstration about fundamental frequency. So for this case, we have stationary waves on a vibrating string. And also we have signal generator, we have pulley string vibrator, and also we have weight. So let's start our experiment. So for this case, first we have to switch on our signal generator. I switched it on, and here you can see the hertz, the frequency of the system. So I am changing, look, I am changing it to 100, and when I did it to 100, fundamental mode of vibration, first harmonic, and fundamental frequency. You see L is equal to wavelength over 2, so wavelength will be 2L. Then let me double it. I will take it to 200, and when I make it 200, so you can see that we have two antinodes. We have two antinodes here, first and second. We have three nodes, 1, 2, 3, and second harmonic to frequency. Let me make it to 3. So you can see that the number of antinode is increasing. The number of node is also increasing, and the formula here. So L is equal to 3 wavelengths over 2. Let me make it 400. So I'm making it as 400. Give me some time. Yeah, when I made it a 400, I have 4 antinodes. I have also increased the number of nodes, and the formula gets fourth harmonic. L is equal to 2 wavelengths. So it was also a demonstration about the fundamental frequencies. So, dear students, here we will also have a demonstration about stationary wave, true or false. So let's first look for the questions. Are the statements about stationary waves true or false? Antinodes always have zero displacement. Dear students, what do you think? Antinodes always have zero displacement. So at this point, I will use my answer as a false. I will also check. We will also say particles on either side of a node are moving in opposite direction. At this question, I will use my answer as a true. Particles between adjacent nodes are in phase with one another. So I don't know which answer you will use, but I will use my answer as a true. I'm using a true. If a string vibrates at its fundamental frequency, the distance between ends is equal to the wavelength. I want here to use my false answer. If a string vibrates at its first harmonic at 200 Hz, further harmonics will occur 400, 600. So for this, I also want to use my true answer. So as you see, my first answer false, second, third true, fourth answer false, and fifth answer is true. So let's check. Let's check what is the result. So dear students, you have seen that we did it well, and it's all okay. So the answer which we gave here, all true, so all okay. Then we have here also some more summary activities for this case, and I think about the summary activities we will speak with you for our next lesson, and I am finishing my lesson at this point. So dear students, I hope everything was clear, and if you will have an answer, if you have some questions, sorry, I'm waiting for your questions and I will answer for them. So see you for the next lesson. See you soon.